So let's look at a concept called linear and angular speed. So to introduce this topic, let's first talk about just in general speed or velocity. Let's say I have a point A and I'm running along that point to a point B. And so the distance from A to B is just D. And we're running along, so here we are. And T is our time. So if we traveled D distance over T time, what was our speed? Well, speed, or velocity, is distance over time. Okay, so that makes sense. If you go a certain amount of feet in a certain amount of seconds, you'd have feet per second. And if you're driving a car, you go a certain amount of miles over a certain amount of hours, you have miles per hour, and so forth. Okay, now this is on a straight line. When we talk about linear speed, so we'll first talk about linear speed, we're going from a straight line and we're going to a curved or circle. So let's say we're running on a circle. Now we are running in a circle. So kind of be like a track, but a very specifically circular track. And so we're traveling, let's see, let's go to the center, from A to B, and we're going theta. This is R, and we're going a distance S. And so S is our arc length. All right, now remember that speed is still distance over time. But in this case, the distance isn't a straight line distance, it's a curved distance. And that curved distance is the arc length. So our speed is actually going to be arc length over time. And so this is what we're going to call linear speed. So linear speed, all right, and then we have this Greek letter nu, it looks like kind of like a V that's curved, equals S over T, which is arc length over time. So essentially, linear speed is, if I were to take this whole distance and straighten it out and figure out how long it takes me to go over that straight line distance, that would be our linear speed. All right, now the next thing we need to look at is angular speed. So instead of talking about how fast we're running, now we're going to talk about how fast are we spinning. So if we have a circle again, and let's say we are here, we go there, and we spin theta radians. All right, so in this case, instead of saying we're going a certain distance over time, okay, our speed is going to be angle measure over time. Now, angle measure is theta, and time is still t. And so that is our angular velocity or angular speed. So our angular speed, now to indicate an angular speed, we have this thing that looks like a W. It's actually a lowercase omega. and that's going to equal theta over time, which is angle measure over time. All right, so what we're doing here is we're looking at what happens as we're rotating something. So if you think of this as a wheel, we're rotating this wheel, and we want to know, well, how far is it traveling around, then that is our linear speed. If you're asking how fast is it spinning, that is our angular speed. Okay? So linear speed is how fast the position is changing, or how fast the object is moving. Linear speed measures how fast an object is moving, okay, and that's distance over time. Angular speed measures how fast an object is rotating. And that is in radians over time. Okay, now just to make sure we're clear on how this works, I'm going to take another little piece of paper here. Let's get this up. Let's say we have this object here. Here's the center. Okay, we have 2 points. We have point A and point B. And the thing goes over here, and B goes over here. So here is A prime and B prime. So we have 2 points on, let's say, a wheel, and it spins around. Okay. Now, which point has faster linear speed? And in this case, it's going to be point B. Right? And the reason it's point B is because, I mean, think about if you're running on a track. You know, when you run on a track, the person who's on the inside has less distance to go than the person on the outside. So in order for A and B to end up at the same spot at the same time, B has to go a lot faster. So you can, if you ever see those, like, you know, in those bands or something where they get in a line and they start rotating, you know, the person in the middle is just sitting there kind of just not going anywhere. They're just moving their legs and spinning around. And then the person way out here has to actually go really, really fast to keep up with the line. So it's the same idea. So point B has a faster linear speed. Now, which point has a faster angular speed, though? Now, in this case, that's actually a trick question, because A and B rotate the same amount in the same amount of time. So they actually have the same angular speed. You know, if they go pi over 2 radians in 2 seconds, it's still the same amount of angular speed. They had to rotate the same amount in the same amount of time. But B definitely has much faster linear speed. Alright, so in the next videos we'll do a couple of examples with this, but here's a quick introduction to linear speed and angular speed. And linear speed has to do with how long it takes me to cover a certain distance, and angular speed is how long does it take me to spin or rotate, and how fast we're doing both of those.